Hello everyone. This is our next question for nodal analysis. And if you see the circuit in which there is one current source and two voltage sources in the circuit, so the current source defines the branch current and the voltage source connected between the nodes but does not contain any branch resistance. So let's see the solution for this type of circuit so that we can give solution in a simpler way. So let's see. In this circuit there are total 4 nodes. This is our node 1, this is our node 2, this is our node 3 and this is our node 4. And we have to assume one node as a reference node. So if you select node 2 as a reference node, then node 1, node 4 and node 3 will be defined by some basic equations. And if you select node 1 or node 3 as a reference node, so in that case one node voltage will be defined and other node voltage will be calculated in terms of previous node. So there is one more option. You can select node 4 as a reference node. It will give the very simplest solution. If you select node 4 as a reference node, then the node 1 and node 3 voltage we can define directly. So let's see. Here we will assume node 4 as a reference node. So select node 4 as a reference node, that is at 0 volt. Now node 1 is at V1 volt, this is at V2 volt, node 3 at V3 and node 4 is assuming at 0 volt. Now branch current for node 1, I1, I2 and I3. For node 4, I2 is already defined, this is I4 and this is I5. For node 3, I3 and I5 already defined, so this is our branch current I6. So first we see the individual source voltages so that we can calculate node voltages. So here if you see a 20 volt voltage source which is connected between node 4 and node 3, and we are assuming the branch current is I5 flowing from 4 to 3 and node 4 as 0 volt and node 3 at V3 volt, and this is our plus terminal, this is our minus terminal according to current direction. So here we can write 0 minus 20 from node 4 to node 3 minus 20 minus V3 is equals to 0. So here we get V3 is equals to minus 20 volt. Now let's see another source, that is 10 volt, which is connected between node 1 and node 4, assuming branch current is I2 and node 1 is at V1 volt, node 4 at 0 volt according to current direction. This is our plus terminal, this is a minus terminal. So here you can write the equation from 1 to 4, that is V1 plus 10 minus 0 is equals to 0, that is V1 is equals to minus 10 volt. So here we see All the three node voltages are defined. V1 at minus 10 volt, V4 is 0 volt, and V3 is minus 20 volt. Only node 2 voltage we can calculate. So apply KCL at node 2 for calculating the voltage V2. So here apply KCL at node 2. At node 2, I1 is outgoing current and I4 and I6 are incoming current. So I1 is equals to I4 plus I6. If you see the value, I1 is 4 ampere, same current source direction. I4 is flowing from node 4 to node 2, initial voltage 0 minus final voltage V2 divided by branch resistance 10 ohm. Now see the value of I6. I6 is flowing from node 3 to node 2 in 10 ohm resistance. So initial voltage V3 minus final voltage V2 divided by branch resistance 10 ohm. Put all these values. This is 4 is equals to minus V2 divided by 10 plus V3 minus V2 divided by 10. Take LCM. This is minus V2 plus V3 minus V2. So here you can write 40 is equals to V3 minus 2V2. As we calculated, V3 is equals to minus 20 volts. So you can write minus 20 minus 2V2. So here we get minus 2V2 is equals to 60 volt and V2 is equals to minus 30 volt. Now calculate current in AB branch. So you can write current in AB branch, that is I6 is equals to V3 minus V2 divided by 10. So here V3 is minus 20 minus V2 is minus 30 divided by 10. So here minus 20 plus 30 minus 20 plus 30 divided by 10. So you will get 10 divided by 10. So here I6 is calculated as 1 ampere. So this is our answer for branch current AB. So here we see the circuit solution become much simpler if you select the reference node carefully. Thank you. Thank you for watching the concept. Please like and subscribe my channel.